Good evening, ladies and gentlemen, and welcome to the webinar Driving Value to Performance Manufacturing Excellence, powered by Swelect Energy Systems Limited, a leading solar power systems company with a strong presence in global energy market for over 40 years. Swelect's core strength lies in technical expertise, which is strongly backed with state-of-art manufacturing facilities for solar PV modules, solar PCUs, servo stabilizers, structural and electrical balance of systems, such as module mounting structures, AJBs, etc. Swelect is recognized as Tier 1 solar PV module manufacturer by Bloomberg New Energy Finance, the highly recognized global industry standard in classifying solar photovoltaic module manufacturers. Swelect has also received certification from the Bureau of Indian Standards for solar PV modules, including the high efficiency PERC modules. With over 40 years of field experience and with a team of experts in power electronics, Swelect even today stays close to its customers and caters to the needs through continuous technological innovation, rich expertise, and customer-centric approach. Swelect has the ability to implement solar power projects in small as well as large scales with utmost understanding of customer requirements and customized solutions. The webinar is being moderated by Mr. Dhruv Warrior, Program Associate, Council on Energy, Environment and Water. And introducing our panelists, we have Mr. K.V. Nachiappan, Director, Swelect Energy, Mr. Krishna Arjun, AVP Technology, Swelect Energy, Mr. Manish Asija, Founder and Managing Director, N Possibilities Private Limited, Mr. Sridhar Sundaram, Assistant General Manager, Maintenance and Projects, Swingstetter, India Private Limited. We will start with the presentation from Swelect, for which I request Mr. Krishna Arjun, AVP Technology, Swelect Energy, followed by the presentation from Mr. K.V. Nachiappan, Director, Swelect Energy. Mr. Arjun, please. Arjunji, you can start, please. You're on mute.
Yes. Good evening, all. Today we are covering a few slides about our value proposition on module manufacturing or the manufacturing excellence. We are from Swelect, and we are into this industry from last 40 years. And over last 40 years of experience, we have in both power electronics and renewable energy sources, and it's basically wind, solar, wind, and electronics. That's the Swelect stands for. And we incorporated this Swelect in 1984, and we are a public listed company, which is listed in both the BSE and NSE in 1996. We are one of the leading manufacturers of solar modules, MMS structures, and balance of systems. Of course, we have three verticals, like we are independent power producers, of course, module manufacturers, and captive power plants, and as well as EPC. We are global presence. We have two manufacturing locations in India, which is located in Coimbatore, where we manufacture our solar modules, which is having a capacity of 1 gigawatt at stringer level. And we also have a manufacturing location, another location at Salem, close to Coimbatore, where we manufacture our bill of materials like BOS, balance of systems, like structures, AGB and DCDB, all that. And we also have a few IPP projects and captive projects at surrounded in Karnataka and Tamil Nadu. We have a registered office in Singapore as well as US. Coming to the core topic today's webinar, performance manufacturing excellence. That's the core topic today. And in today's world, the solar energy is rapidly growing source of clean and renewable power. And if we put this together, or the manufacturing excellence, it depends on the four key pillars for high performance solar module manufacturing. Performance of the module manufacturing is not just by producing or setting up a quick lines and making the modules. It depends. It depends on how well we balance between these four parameters or the four pillars. First pillar, we can say that performance. The second is cost and sustainability and supplier reliability. When we come to our performance comes with an ensuring the material is meeting the highest quality standards or whatever the BOM material we're choosing. And the cost, we need to optimize the cost as we are in a competitive world and it's a very competitive market. So we need to optimize the cost of the BOM. And sustainability comes with selecting bill of material, which is having an end of the life. It should be recyclable and it should be reusable. And of course, supplier reliability. Supplier reliability, we need to have a long-term contracts or the agreements of the reliable supplier, ensure that they deliver the right material with the right quality every time. Coming to our bill of materials, we have around 6 key components in the module. The first is solar cell. The solar cell is like which converts basically the sunlight into electrical energy. The solar cell, what we're choosing for our modules is the key component, and how we optimize what we purchase of the solar cell is key factor for the module in order to perform at the field. And the encapsulant is an EVA or POE or PE material, which holds or laminate the module with cells and backsheet. It should have good transparency and waterproof, proof, and having a good mechanical properties. And the front glass is the outer surface of the module, which is facing the sun, where the light it takes the light in, and the thickness of the glass plays a major role while selecting the components in the solar module. Coming to our backsheet. Again, the backsheet is made up of 3 layers. The backsheet is very critical in solar module, where we see the backside of the module. It's generally, it will be white in color. And it is made with 3 layers. We'll cover much more in the upcoming slides. And the junction box and cables, and the junction box cables are also key components in our module, where it should be UV protected and it should have IP68 minimum SR rating. And the aluminum frame, which surrounds the glass or this laminate complete together, is an aluminum frame with a strong aluminum frame, which stands our strong wind, snow, and other physical stress and excellent moisture corrosion. Coming to all this put together, choosing the right BOM material and the right combination, the strong BOM. If you put very simple, we can say that the frame the alloy of the frame is more critical while choosing the frame, is 6005 or T6 or even the better alloys. Or the glass is 3.2 thickness and its transmitter is 93.8. EVA thickness, generally people think that it's an EVA, but the thickness of the EVA plays a major role, as well as the GSM of the EVA. So when we see a module between the competitors or between the different suppliers, we really look at this BOM, what really the BOM is going into the module and what is the thickness or what is GSM they are using. In the same way, in the backsheet, whether it's fluoro-based backsheet, potent backsheet, or the different types of backsheets are available these days, we need to choose which backsheet is better. And junction box is IP68 rated or even IP65 or what it's rated. So with this strong 4 pillars and the BOM in place and a pretty much good system in place at the manufacturing location, like product development, manufacturing quality and reliability program in place, backed up with the strong documentation and employee motivation, for sure the module what we design at our plant will stand for 30+ years in the field. This is our testimonial, or we can say with a strong BOM, what we make the module with good workmanship. The degradation much allowed in as per IEC is like 5% degradation, but we saw the module degrades even much lesser than 5%. It's close to like 2% in our damp heat. Otherwise, it's not even 1% anywhere in the degradation. This is for bifacial modules, the degradation after the IEC testing. And this is for TopCon. We see that is in the TopCon also, the glass-to-glass TopCon module. The degradation is much lesser than what is the IEC's requirement. It is just 2%, less than 2% everywhere. And thermal cycling, it's only 1.8. Otherwise, we are at much less than 1%. Coming to our portfolio, we have different module types: glass to white backsheet, glass to transparent backsheet, glass to glass to black backsheet, and glass to glass backsheet. With this, thanks for your valuable time. With this, we briefly touch about our manufacturing or the manufacturing good practices which are there in the industry. From here, I'll hand over to Mr. Nachiyappan to take it forward for the next presentation. Thank you.
Thank you, Arjun.
It's all good, sir.
All good. So, okay.
No, it was all good. I think you need to do it again. Perfect.
Yeah. So, hello and welcome once again to today's session. Thank you for being here today. And as Arjun just spoke, you just heard the high standards that Swelect practices in PV module manufacturing to achieve quality objectives. Further, I have the pleasure of walking you through a few slides that portray the high manufacturing standards in synergy with the best-in-class energy plants that deliver the highest level of energy performance for its customers. So at the outset, Swelect has executed more than 300 megawatt of projects covering utility projects, rooftops, solar water pumps, energy storage. And what you see here is a snapshot of the 300 megawatt of utility scale projects that we have done. Over 50 plants covering 15 locations, over 450 million units generated in the last financial year at the rate of almost 80% performance ratio and a capacity utilization factor of greater than 16%. And all this with 99% uptime. Moving on to our rooftop and ground mount plants, Swelect is also a leader in the rooftop space. As you can see here, over 50 megawatts in major installations around the country, let it be the United Nations building in Delhi or others. We've done excellent work for our customers. And overall, Swelect has a rich experience of 40 years of experience in power conditioning, power quality, renewable energy, and in various aspects of the renewable energy field. Next up, we would like to walk you through a few points on enhancing the life of PV modules. As we saw in Arjun's presentation, the high standards in correlation and in synergy with that, it's key to maintain the health of the PV modules in the plant. So PV modules being the most important part of or the heart of any solar plant needs periodic examination, testing for its any deficiencies that can arise at any point of time, like in any other equipment worldwide. Test will minimize the failures with PV modules and extend the operating life. Generally, we see a kind of infant or what we call as teething problems initially, the ones that you see in the initial years, like glass breakage and the junction box and loose frames. Well, Swelect really overcomes these by with its manufacturing excellence, and all in line with IEC 61215. Further, the midlife phase or the most useful phase where Swelect adheres to proper soiling losses cleaning ensuring no shadows on PV modules, and optimizing electrical connections. Some of these methods are really recommended, and best practices are followed at Swelect to ensure to maximize energy generation. And last but not the least, the wear out phase, of course, is also taken care by the high standards that Swelect follows. Moving on, the annual health check routine, like any other equipment, is the key to enhancing the life of our PV module. So what you see here are 5 key tests that really help to maintain the maximum energy throughput of any solar plant. To start up with, the flash test is a key, followed by the IV curve test, which really tells you any discrepancies and really warns you of any underperformance at any point of time. Insulation resistance to determine any dielectric loss and leading to unexpected shutdown. Visual thermographic tests, which really help us detect any cells that could go wrong at any point of time and predict any upfront failures. So overall, we follow what these 5 key tests are in the matrix, which really help in maintaining the plant. So to sum it up all, Swelect is a one-stop solution for PV module needs or PV power needs, starting from, you name it, from the segmentation of channel business. Mr. Manish is also here. So product distribution, or name it the rooftop projects that we do directly or through our partners. EPC projects, which we do for our customers with the best-in-class engineering and products. IPP projects, which are our own development projects, where we supply energy to our customers. And finally, special projects like India's first solar floating project for NTPC, and also projects which are related to residential and others. So overall, Swelect is a one-stop solution for all its solar needs. And I would really say an all-rounder. And that's it from me. Thank you for your attention. Over to you, Amit.
Thank you. Thank you for the presentation, Nachapan sir. And thank you, Mr. Krishna Arjun. I request all our audience to keep sending their questions through the chat, preferably marking it to the individual panelists. And now I invite our moderator, Mr. Dhruv, to take forward the panel discussion. Dhruv, please.
Yeah, thank you so much, Amit. That was a great set of presentations, and I'm hoping that in the following panel discussion, we're able to understand the loop of how manufacturing excellence and this linkage between cost, performance, and competitiveness translates from manufacturers through to distributors, and then finally to the end user. So I'm Dhruv Warrior. As Amit had said already, I'm a program associate with the Council on Energy, Environment, and Water. We look into policy solutions to scale up domestic manufacturing of clean energy technologies. And understanding some of these interlinkages will be very useful both for end users, but also for the broader ecosystem. So I'll dive right in. Just as a few housekeeping notes, the panel discussion is planned to be between 35 and 40 minutes. So I hope the speakers stick to these predefined timelines. Once I ask the question, I would also request speakers to introduce themselves, maybe provide a bit more background on how their expertise is relevant to the discussion. And of course, we will open up for questions immediately after the panel discussion. So yes, looking forward to an engaging discussion. Let me start with Mr. Arjun. So Mr. Arjun, I wanted to ask, how do you as a manufacturer gauge user preferences when it comes to solar module performance? And how do you understand what it is that users need and then work towards it? So yes, over to you, Mr. Arjun.
Yes, See, there are a couple of ways how we gauge what market requires and what we are manufacturing. Let us put in simple. We put it at direct method and indirect method. Indirect method, we get direct feedbacks from customers or our developers or whoever this end customer, and by surveys, customer feedbacks, customer surveys. And in the direct method is one more called market research, what market is really want and where the market is going. So these two comes under direct method, which we keep on getting the data from the field, what is happening at the marketplace. And in indirect method, we get market trend and sales data and the competitor analysis, like what competitors are doing and what really happening in the market. Like we have a big competition from China, what is happening there, and of course industry regulations and standards, where we have a couple of regulations and standards from Government of India and other parts of other local governments, state governments, and online reviews, social media, and all. So if you put in nutshell, like two, we get direct and indirect. Indirect directly, who are our customers who are buying modules directly from us, and in the indirect way, we get the feedback from the competitors of the market survey. So with this, we gauge what we are manufacturing really meeting the customer requirements or the local government requirements and all. Additionally, we also get a different kind of information or a variety of information from regional variants, like the module design or the module requirements or the standards required varies from region to region. So it's not like one standard can work for entire world. There's different countries have different standards. So we need to look up at that as well while gauging. And coming to our performance of the module at the site or the field, we always keep, as in, of course, as we are in Swelect, we have an EPC division as well and IPP division as well. So we generally take the data from our sites and we monitor what is the performance with respect to different BOM combinations, what we use in manufacturing, and how it is delivering based on that PU system or simulated data, whether generation is up to the mark or even less or higher than the rated one. This how we get the information from the market and we check the performance of the sites. Yes.
Great. Thank you so much, Mr. Arjun. Maybe taking this to a logical next step. Of course, I think it was very interesting understanding how different direct and indirect feedback methods are used. But I'd like to now move on to Mr. Manish, who's a distributor, and of course, perhaps with greater visibility of the market and better understanding of what the market looks like, or maybe a different understanding. So, Mr. Manish, building on what Mr. Arjun said, how are you as a distributor positioning these modules, which are available currently on the Indian market? And have you seen some kind of segmentation in terms of user demand coming from different domestic consumers, whether it's residential or commercial or industrial? So I'd love to hear your thoughts on that.
Thank you, Dhruv. This is an very interesting question. Okay, given that we have been working with EPCs across India, so I like to just consolidate what I have learned from my last 7-8 years experience as a distributor and share with the audience. Before that, as you said, I need to introduce myself. So yes, I am Manish Asija, founder and managing director of N Possibilities. We are a 7-year young startup and having supplied over 800 megawatt plus solar products to over 1,000 plus EPCs across India. We are a leading distributor of solar modules and solar inverters. And we operate from 8 locations: Coimbatore, Cochin, Chennai, Bangalore, Hyderabad, Pune, Ahmedabad, and Gurgaon. We have operational warehouses with stocks there. So coming back to your question, as a distributor, and my fellow distributors across the country, they position modules by considering variety of factors, and these could be quality and performance. These could be brand reputation of the organization manufacturing it. This could be technology or cost effectiveness, which is very important for Indian perspective, and customer segmentation. So I would like to touch upon each of these very briefly. So quality and performance is very critical. Okay, modules are being like segmented or positioned based on the efficiency that they are operating upon, the durability and performance trends in actual site and climatic conditions. Okay, example, high efficiency modules from very premium brands are mostly preferred in commercial and industrial establishments. Okay, whereas nominal like manufacturer or a small unit manufacturer, their modules are being considered mostly in the residential segment. Okay, so most of us would have heard about various like quality issues arising in the modules in the field. These random cases could be like module output power is not satisfactory, or there are earthing issues or PID issues, or even there can be visible issues like snail trails, hotspots, decolorization of cells, or loose frames, water intrusions. All these things are basically like poor quality assurance process at manufacturer end, and sometimes workmanship of the installers also. And this is not like related to any one particular make or any one particular brand. So what is needed, okay, is to ensure that while selecting any manufacturer, we need to understand their quality standards, and that they believe in the quality and performance oriented manufacturing. So second aspect was brand reputation. In my experience, I have seen established brands with proven history of reliable performance and having a strong corporate governance, especially few large listed companies. Okay, they have a good market presence and are generally preferred in larger commercial projects. And EPC players also would want to like highlight these brand names when they are proposing to their clients. Third aspect was technology, very important factor. Like we can segment or position modules with the way of what kind of modules these are. Like it can be P-type monopark module, or it can be N-top one. So this is a key differentiator. And what we have seen is N-top one modules these days are coming up with very high efficiency, better performance parameters, and they are marketed both in the high-end residential or commercial projects as well as large industrial or utility projects. So there is a research which was conducted recently in China by TUV Node, which is showing very interesting results. It says 3% higher generation is achieved in N-type modules when compared to P-type modules for same rating. It also says there is a BOS saving of almost 1% for the same capacity of plant when you use N-type instead of P-type. And this study was conducted in a 120 megawatt plant. So the LCOE, as stated by that report, is almost 4% lesser. So this is a very interesting positioning. Like this clearly creates a case why industry is shifting from P-type to N-type so soon. Okay, so this has various reasons. We can discuss that in detail. If someone has question, I can share the details. So last means next was cost effectiveness. India is a very price sensitive market. So for residential customers, especially, cost plays a very significant role. Even large EPCs, they would want to go with probably high-end modules if the projects are for IPP modes or for the RESCO or OPEX modes. And if it is just EPC, they would like to go with mid-tier or maybe a budget-friendly DC, any kind of module. So this we have seen that affordability is sometimes considered more important than the performance of the module. And last parameter on segmentation or positioning was commercial versus domestic. That was your second part of question. So interestingly, like usage patterns of domestic and commercial customers are different. Commercial installations might operate for very long hours and have very high energy demands during the day. So this influences their choice. They want to go with more durable and very high performing modules with a proven history. Whereas residential customers may have very low overall energy requirement. So, and these are less aware customers. So EPCs dictate what kind of modules can go to these kind of projects. So same way, commercial consumers generally require very high power output per square meter of area available, because generally industrial sheds will have 8, 10, 20 megawatt loads, but the sheds available can accommodate only like 1 megawatt or 2 megawatts of modules. Even land is very costly these days. So those guys will look for very high end like 600 watt peak plus modules. So that is another factor that comes into it. And last is this PM Surya Graha Yojana. So this one has really created a buzz in the market in last 3 to 4 months, thereby causing a shortage of PCR modules and increasing the price significantly. So having said above, some residential consumers may go for even high energy needs or high end modules, but mostly it is mid tier or low priced modules that they go for, and commercial and industrial majorly goes for the high end modules. So I hope I was able to answer your question.
Yes, got it, Mr. Manish. I am sorry I actually dropped out in the middle because I lost power, but I got most of what you shared. Thank you so much. Um, I'll quickly just move over to Mr. Nachiappan, because as you said, there's a lot of different characteristics that a lot of these consumers are looking for, and the kind of way that you are positioning these modules, including corporate governance, technology, various kinds of efficiency factors, the brand value. One thing that I would really like to dive into a little deeper is to understand uh, where, while performance is something that a brand can work towards at a manufacturing level and in terms of R&D, there's always a gap between that and what is experienced on the field, especially given the longevity of these solar panels and the fact that they need to last in the field for 20 years and achieve basically this kind of excellence over a long period of time. So, Mr. Nachiappan, I was wondering, what are the real gaps between what is worked towards in the lab versus the impacts that you are able to achieve on the field? And what are the causes of some of these gaps? Mr. Nachiappan, I think you're muted.
Sorry about that. Thank you, Mr. Dhruv, and hello everyone. This is Nachiappan here. I am proud to be associated with the Swelect family for the last 3.5 decades. I manage the project services and maintenance for Swelect. And your question has two parts to it. I would say one that is more related to the environment part, and the other one more related to the module degradation part. So I would really face it in two parts. Environmental issues, which are real world conditions, because lab tests often occur under ideal conditions, and therefore harsh weather actually makes a differential factor in really determining the performance of the module. Module degradation also is another factor which lab conditions may not be able to, in the past at least, actually simulate. The next part would be the integration and the sub-level, system-level issues, which are basically balance of system components and module interconnectivities, and things that are to do with the efficiencies of the entire plant. So in terms of the real world conditions and the module degradation, there are, of course, solutions today, and there are gaps that can be really addressed. Therefore, I would really say one of the key examples of the focus on manufacturability and the key initiatives taken by Swelect, as you saw, researchers are also developing new cell technologies that are easier, most cost-effective to produce at scale. We saw Mr. Manish explain a few of those. And we also have material science advancements, which are really improving the purification techniques and exploring alternative materials as an answer to reaching specified versus actual conditions at the plant level. Realistic testing procedures is another initiative that is really closing in on the gap between test conditions at the plant versus the field. And finally, module level innovations, which are basically ARC coatings, bifacial designs, light trapping techniques, and also the newer technologies like what we just heard, the TopCon and N-type taking over and being really efficient and long-lasting. So I think I hope I explained that although there is a difference between what you see in the lab and what you really experience in the field, these are really being bridged with newer technologies and advancements towards bridging that gap. Thank you, Dhruv.
Thank you. Thank you so much, Mr. Ashok. And I think I'll come back to you a little later to also ask, perhaps from the developer's perspective, is there something? But that's something that we'll get to. Before that, I'd like to turn to Mr. Sridhar now. Mr. Sridhar, of course, we've heard many perspectives, whether it is from the manufacturers or the distributors. But I think it's important that we hear from the horse's mouth, what is, as an end user, what are you looking for when it comes to performance of these solar modules? And essentially, what is your kind of prioritization? Because, of course, there are many different things to prioritize when it comes to a solar module. So what are you looking for? Yes.
Thank you, Dhruv. Good evening, all. I'm Sridhar from Swing Trader. I'm the end user of Swelect panels. See, we have been using solar panels for last 14 years. Since 2010, we've been using. But before selecting panels, the primary criteria would be we want to go with a reliable partner, because we want to sustain this power generation for minimum 20 years. So there are many traders who can sell, and after 10 years, 5 years or 10 years, they will not be in the market. So when we go for a huge investments or bigger solar projects, so we want to go with a reliable partner. That is the first criteria. We want to go with the manufacturers, not with the traders. The two, the manufacturing in India. Second, the performance, the reliability, and output of the panels, because we are going to invest for our factory, which we are going to consume. So if you are trading, that is a different scenario. If it is consumed by us, so you want to have a better performance. So when you screening the process, there are many people, more than 10 vendors who are participate in this. But finally, the option we select was Swelect, because of their we have visited their plant, the panel manufacturing process. From starting to end, the complete process was automated. So the output, what they achieved, what they committed, we are able to achieve consistently. Last 3 months, we are getting whatever assured, it's more than that they are giving. This is a process, and this is the criteria to select. Thank you.
Thank you, Mr. Sridhar. Maybe Arjun, just coming back to you, working on now, just coming back to this. Now, I think we've heard that there are these kind of performance requirements. I would like to ask, was there a challenge in getting the technology required to meet the kind of performance requirements that we have heard from Mr. Manish or Mr. Sridhar? And more importantly, is that something that says, is there any systemic issue at maybe a policy level or at a market level in getting access to this? Or is this something which is really down to a company strategy when it comes to getting access to these technologies? With Mr. Arjun, I think you're muted.
Yes, there are challenges. Let me put very simple. India is like fast runner behind China, if you ask me in a simple one line, because the technology is matured or proven in Chinese market or Chinese manufacturers. Then we take it to India and we just put it here. Yes, they are mainly because we don't have any polysilicon manufacturing in India as of now, and people are still trying. We're not there, but we are trying. We'll be up there by some time. That is one major setback in India, because the complete ecosystem from the polysilicon to the module or the field, we don't have much. We have more capacities at the modules. and somewhat at cells. And it's almost like negligible capacity in polysilicon at the wafer level today in market. So once this value chain comes up, then we'll be also at technology driving country where we put this upcoming technologies first place in India. So having said that, see, the government incentives are there in place, like PLI schemes and other set of schemes are there, and where we can push this. But now still in the China, in India, we depend most of our raw materials from China, basically. That's another stopping us to innovate in the new product or a new technology getting together. And coming to what Manish said, what Mr. Manish said, that yes, N-type is really picking up and TOPCon is picking up, and we have some advantages for P-type. For sure, yes, we have advantages for P-type, and India manufacturers, cell manufacturers, some capacities are coming with TOPCon now. And of course, the module manufacturers, even most of our module manufacturers are already there at the TOPCon, and they'll be commercially launching this product. Already few manufacturers launched it, and few more are launching maybe in August, September, this time. And so in that way, we can say that we are there, but we are a bit slow compared to Chinese suppliers. That's only thing.
Yeah, I think that's a very useful insight, and I think that's something that we need to really address at a larger ecosystem level. But yeah, I would say one of the ways that we have realized that the government is trying to address it is by creating maybe a more protected space in India, whether it's through tariff barriers like BCD or non-tariff barriers of some kind. Of course, the ALMM list has now basically exemptions have been removed for most manufacturers. I would say the question is, on the one hand, of course, this supports technology development, domestic, and it allows the domestic industry to develop. But I would turn to Mr. Manish and ask, has this caused any kind of issues when it comes to access to certain technologies or some levels of performance in the Indian market, or have we still been able to achieve that level of performance within the domestic market to meet whatever the requirements are for end users that you're meeting?
So this approved list of module manufacturers, models and manufacturer, or the basic custom duty, two topics you have touched upon. Both I will try to put my views on. So these are imposed by Indian government and have significant impact on the business performance in India, whether it is availability of solar modules in Indian market, or it is like the pricing dynamics that has changed over last few months. So basically, Indian government has come up with this ALMM with an objective to ensure that only high-end, high-quality modules, are manufactured in India, meeting very, very stringent Indian standards, and are used in all government projects and all net metering installations. And this has first I'll talk some positives about it, and then how it has impacted the business. Both things I'll try to touch upon. So this has led to overall improvement in the performance and reliability of available Indian modules. And any substandard product from Indian manufacturers are filtered out. So that's one positive out of the ALMM. The imposition of ALMM has actually limited the choices available to the customers. Now, with respect to large installations in especially commercial and industrial space, there are in fact set of customers who still want to use the tier 1 top and top 5 makes of China. These guys are now not able to get the products, so this might have reduced overall project execution pace, and the targets of government will get impacted a little. And this might also reduce the variety of high performance modules available in the market, potentially affecting competition, and it can lead to even kind of reluctance or some kind of price escalations, okay, in the market. So this also acts as an entry barrier for especially new entrants. In past, there are new companies who wants to get into solar. Okay, they have acquired technology from China or Europe. They have acquired all the machinery. They have all the resources available to immediately start. But getting into ALMM list is again a tedious process and will take 1 year. So more solar players or manufacturers will face entry barrier because of ALMM. So similarly with BCD, like 40% on solar modules is huge. Okay. Along with that, there is 10% surcharge on it, and 25% on solar cells is imposed. So this is making like Indian modules less competitive. Okay. This means, Chinese products, even after duty, they were cheaper than Indian counterparts. This was observed when ALMM was not imposed. Okay, so this has led to a very high project cost to end customer. End customers went on back foot thanks to the international dynamics where the prices fell remarkably. Okay, the base product pricing. So this impact was minimized in last 1 year. So another factor, the imposition of PCD was aimed at promoting domestic manufacturing. Okay, and this has led to increase in investments in local production facilities, and this has really improved quality and performance of domestically produced modules over time. And in short term, like imposition of BCD has led to disruption in supply chain. So project delays have happened. Okay, a lot of price changes happened during this time. So I'll say there has been an overall increase in cost of solar installation due to higher prices of both imported and domestically produced modules due to these two phenomena. And consumer or customers might face higher upfront cost even in future. Okay, but long-term benefit of using high quality Indian ALMM approved makes. Okay, these will be like more reliable modules, and these can offset these small short-term cost increases that have happened in the market. And both these policies are actually pushing market towards a greater self-reliance, I'll say, and improved quality controls. So initial phase there were some market adjustments, and in long term, I think these will foster innovation and grow the domestic solar market. So this is from my side.
Yeah, sorry. Thank you, Mr. Manish. And I think that's a very difficult conundrum that we are all trying to solve. It's something that even at CW, it's a question that we have asked, and even not just how much BCD, but even at which stage of the value chain should these kind of tariffs be put in, and to what extent should indigenization happen. So I think that was a very interesting take from you. Mr. Nashyapan, I think I'll come to you at the end to close. But before that, I'd just like to bring Mr. Sridhar in, just because we were talking about the competitiveness of domestic modules versus modules outside. I think a broader question is, how do you take a decision, given that as an end user, you have to take a call between going not just between different modules, but also between solar and clean energy technologies versus just having either a grid connection or some kind of captive thermal power or any other sort of power. How do you take this decision to go for the decarbonization option? Is it an obvious decision for you? Is it something that is the most cost competitive? Are there many different factors that you've had to consider, considering the current way that the Indian market is and the current accessible technologies? So yeah, over to you, Mr. Sridhar.
Yeah, see, first in 2013, we have started the green energy by external force, like government has brought a new rule. Tamil Nadu government has brought a new rule that 6% of your power should be from green energy. So before that, we have been trying to invest some money on green energy, but our management also little hesitant to go with that. But the rule which has come in 2013, it forces to go for the small investment on green energy to match the requirement. But once we started using this, we are able to realize the benefits, because we are able to see the benefit that we are able to produce more energy on green So it gives more confidence to our management to more invest on green energy. So from there we started. In 2019, actually, we have started a new project. We want to go for a bigger way of green investment, but due to COVID, we could not invest that year. So that's what we want. 1 megawatt was installed recently. The main reason is even a small green energy initiative give a lot of confidence to go with green energy. So that is the base. We start with some force, but once you started realizing the benefit, obviously we want to go for more green energy. Due to some restriction, we are not able to go with immediately. We will go with more. So we are in the process of getting, because though we have a capacity of around 4 megawatt to install inside our plant, we are going with phase wise. So we start with now 1 megawatt. We are in the process of going with more. Comparatively, we have been using a captive power. We have been using even third-party power of other energy, not solar, and we have been using our Tangentco power. But the recent the bigger investment is clearly says that the green energy will give more benefit rather than any other power, any other power. But if it comes to that reliability, yes, there is the green energy. There is some restriction, but we know that we cannot change that. But there are other alternatives. It can be a hybrid. It's a possible. It gives more steady outputs. So we are working on it. Still, it is an early stage for concluding any kind of energy. So at present, we are going with 1 megawatt. Definitely, we go with a hybrid model coming to near future.
Got it.
I hope you
got it. Thank you so much. Yes, that's very useful, and it's really heartening to know that you feel that clean energy is the most competitive, at least for you. Of course, like you said, reliability issues, and perhaps reliability issues are not something that need to be dealt at your level alone, but something that has to happen at a higher level, perhaps at the grid level, and so that's something that will require further planning. Just to close, Mr. Nachiappan, I'd like to turn to you finally, maybe with a brief question about whether there are any operational changes that someone like Mr. Sridhar could make to make clean energy like this more, viable for them, because like we discussed, environmental conditions and a lot of different use cases really affect what is the actual achieved performance. So is there something that can happen at the operational level that would really benefit and could really translate into greater deployment because these technologies become more competitive? And then finally, do you have any broader thoughts on, just at an ecosystem level, how do we really drive a performance in India in the manufacturing sector?
Thank you, Mr. Dhruv. To answer your question, we have obviously we have environmental factors, and then we have operational factors which really impact the performance of the modules. Diving a little deep, environmental factors, temperature, light intensity, and of course, dust, soiling, debris, which is basically bird dropping. These really impact the performance of the modules very, very much. So these are some of the environmental factors, especially temperature is often mistaken for, better light intensity or radiation. So that's about the environmental factor. On the operational factor, of course, module degradation over a period of time really needs to be factored in terms of the performance of the plant. A key among them is the balance of systems, because the losses there really count. And of course, module mismatch, even minor variations there can have a difference in the mismatch within a solar array. But they're not without solutions, and because the key actions that can really help is selection of the site, the right selection of the site, and the analysis, the shading analysis, the type of module tilt angle, the orientation, and regular maintenance, as we saw earlier, monitoring a key aspect of the system diagnostics and performance will play a big role in ensuring performance. Quality of inverter and the balance of systems, a big role it plays. And then finally, the advancement in the module technology. So these are some of the key aspects that really impact the performance for any customer, including Mr. Sridhar, as he just mentioned. So overall, by implementing these optimizing strategies, any developer or contractor can ensure their PV module operates closer to their peak, because the modules are always rated in peak performance, and maximize their energy production over the lifetime of the system. Thank you.
Thank you so much. I feel like we're close to time, so I'm just going to ask a couple of questions that we have received from the audience. I thank you so much to the audience for all your questions, but given the paucity of time, we won't cover all of them. I think first, just as a first question, a very general question that came from the audience from H. Patel, I believe. How is the current demand supply scenario in the industry, and how do you see prices moving further? Given that all of you are in the industry, if anyone would like to take this up, that would be great.
I can take up this.
Sure, please.
I think last week we are in China, and we understand from the industry that it's already the prices are at bottom rock and they're losing money. But at the polysilicon, at cell level, at every level, and then the backward integrator who is having complete like module cells, wafer, polysilicon, and wafer. These are losing more money. So they're losing money, and we are at rock bottom levels in terms of pricing. And definitely in our coming quarter, maybe not this quarter, maybe the next quarter, the prices may shoot up and go to at certain levels. Not at back to our original 1 year back prices, but certainly it should go up. Otherwise, this industry cannot sustain with these lower prices. That's what we understand from the market. And to answer this, yes, in India also the prices may slightly go up, because our right now in India, the most of the BOM is we depend on import today. So naturally, when the import cost goes up, the module price may also go up.
I would like to add on this. Okay, of late we have seen there is a very high increase in the shipping costs from China to India, and raw materials have to come in the same ships. So as high as like 5 times change has already happened, from 800 900 USD per like container to it has gone to 4,500 USD. So that is also going to like show an upward trend going forward.
Sorry. Yeah, thank you. Thank you so much, Mr. Manish, Mr. Arjun. I think that is an interesting topic that we've also been looking into, and the fact that somehow even with rock bottom prices, deployment has not really picked up the way we have seen. Instead, a lot of countries have looked to put up barriers, perhaps, as you said, because these are not sustainable, and potentially it's a lot of dumping that's going on globally in terms of low-cost products. So I think that's very interesting. Amit, do you think we have any more time for questions? Otherwise, we can close the discussion.
Yeah, Dhruv, I think we can take another, we can go ahead with another 5 minutes if you have, if you think that you have.
Perfect. I think there's one interesting question that I wanted to ask, which is on the more technical side, which is how do the degradation mechanisms of N-type TOPCon modules compare to those of traditional P-type PERC? And what are the implications for long-term energy yield? So just broader question about degradation.
I'll take up this. See, now the PERC is much proven in the market, and PERC technology, whether it is glass to glass to backsheet, or glass to bifacial module, is much proven, and the PERC technology is not that sensitive to moisture and UV compared to TopCon. And TopCon is bit sensitive, or the N-type is bit sensitive to moisture and UV compared to Perth. Coming to the performance of both in long term, yes, if module is packaged or the right BOM combination is used, definitely what Manish said, N-type will yield more compared to P-type for now. But the thing is that the right set of BOM material should be there in the place. Like now it's well proven and from the labs or from the field, a TopCon glass to glass is much preferred compared to glass to backsheet, as it's having more barrier towards moisture, first thing. And also people are working with different films to protect our module or TopCon cell from UV rays. That's still picking up, but at the same time, at the cell level, people are working with different chemistry to put that cell resistant to UV. So this going in place now, TopCon glass to glass with the right combination of material and encapsulant like EPE or POE. People move to EPE now. EPE is a sandwich layer between EVA and POE. People are going there where they have better moisture protection for the cell. So this is what it is. But to put it in simple, yes, PERC and TopCon are more or less same now, and we see similar degradations both in terms of PERC and TopCon. Provided TopCon, we should be very choosy in selecting the bill of materials when making TopCon. Yes.
I would like to add 2-3 points to this. Okay, two technical parameters are very important when we talk about degradation. Okay, so one of this is over a period of time how the module will behave. Okay, and there are some accelerated life studies that are conducted in proven labs. Okay, simulation they call that, and then they find how the module behaved in this kind of scenarios. In that kind of study, it was observed that the modules which are N type over a period of 30 years, they came from 100% performance level to around 87% performance level. And modules which were P type, they came from 100% performance levels to 85% performance level in 25th year, not in 30th year. So that's very interesting to see. And the reason that they are giving for this is probably one, they are telling there is a higher bifaciality. Okay. So in P-type modules, whether it is bifacial or it is monofacial, okay, you get around 60 to 70% or 75% bifaciality, whereas in N-TopCon cells, and when it is bifacial, you get around 75 to 85% bifaciality. So this itself provides almost 2% gain of generation, okay, upfront. And there is another concept they have written in the report, lower power temperature coefficient, okay, which clearly states like over a period of time, the output power decreases with increasing temperature. And N-type temperature coefficient is better than the PERC temperature coefficients, and this leads to 0.9% higher average increase in the output. So these are some interesting reports available online. See, if people want, they can study. And then they have conducted IEC tests, and they have seen the reliability of N-type was found to be better. That's the reason probably entire globe is moving very fast to N-type.
Yeah. Thank you, Mr. Manish. Thank you, sir. I think that was very, very interesting, very informative for me as well. Would any of the other speakers want to comment on this? Otherwise, I'll just move on to the next.
Thank you, Mr. Dhruv.
Oh, sure. I'll just the final question then. Again, a very general question that I will address to the manufacturers or even the distributor here. The question is, we want to know what are the issues that as a solar power manufacturer you are facing. So I think it's free. It's a free board basically to share what are the major issues that you can see will, and maybe not just you, but that you see for the Indian manufacturing ecosystem. What would be the kind of next roadblock that they will need to go past? Yeah, over to you.
Anish, you will take up or I'll take up this.
Sir, it is for manufacturers to answer first.
Coming to our manufacturers, now see, we are not so much backward integrated in India. So we are heavily dependent on imports. That's one thing. Of course, we have good support from government, like various schemes which are there in place. At the same time, we also have the schemes are locked up with DCR contents or DCR cells, where in India, the DCR capacity is much lower than module capacity. We don't want to put the numbers, but it is very less. So if the projects or the government schemes are locked with DCR, so eventually we have a module capacity, we are unable to fulfill the requirements. At the end, we are unable to fill the government requirement or the government targets because non-availability of cells. So there should be a give and take thing, like few projects should be linked with DCR and few projects should be open for non-DCR cells as well. That's one big roadblock for manufacturers to utilize full capacity of their installed capacity. That's the thing. And the second thing is government also really need to look at a bigger picture of putting polysilicon plants in India. So that it's a big capital intensive and big power chiseler for the manufacturing of polysilicon. India should look at that level so that the availability of our metal will be in. Other bio of material like glass, EVA, backsheet, all are pretty much coming up in India. Is going at its pace. We think that in another couple of years it will be more or less matching the module capacity. Only the backward from wafer and below, maybe it will take some time. Otherwise, we are there. But yes, it is good for manufacturers now. Now, only thing is we need to run up with the market and catch and achieve the government targets as well. But with filling these gaps like DCR contents and all, we'll sure we will be meeting the targets. Yes.
I would like to add up on this. One of the challenge what I could see as a customer, the module which is produced in India is little costlier than the model which is getting outside. But customers are getting confused which to buy, because if you want to cost effective, definitely the option will be with the model from outside India. But when you come to the reliability, you have to take a call. So because there are labor cost, as Mr. Manish meant, the land cost, all those things you put, set up a factory, it needs a lot of money. So the customer has to little go inside and study on what basis the model cost is brought. If it is purchased from outside, how they are going to, because the models are getting upgraded, whether once you have problems, you are going to replace, then how they are going to replace, those things has to be looked into before purchasing of any models.
I'll just add on here if we have some time. It's module Indian manufacturers. It's a bit costly. We do agree that it's because of economics of scales. In simply put, it's like the capacities over there is like huge, and we are there. That's the one factor which is driving, and the second thing what really we need to look at is India is a typical climate. It's a harsh climate where we have extreme temperatures, extreme winds, and extreme humidities compared to most of the part of the world, we can say. So it's always important, like which bill of material is going into the module. Like if we just discussed in our presentation, if I use 0.5 mm thickness EVA and the other person or other competitor may use 0.2, where the material compromise happens, the cost can be brought it down. But the thing is whether that module is really reliable or durable and considering our harsh climatic condition in India. And the most important thing what I suggest, not as a manufacturer, but in general, I suggest warranty and after sales service. It's the key factor we need to factor in while choosing any modules, whatever we choose. What service we get after sales, and what is the warranty? If my module goes fail, where I need to go and claim. That's the two important factors really we need to consider while choosing the module.
So same thing I was trying to also put up 3 words: availability, affordability, and accessibility when services are required. If these 3 are together, then things are sorted. Otherwise, these are challenges, be it for manufacturer or for the customer or distributor.
Great. Thank you. Thank you so much to all the panelists. I've learned a lot. I'm sure the audiences as well. I'll hand it over to Amit now to close up. Thank you so much.
Dhruv, thank you for moderating the panel and bringing out the best through the webinar. The webinar being driving value through performance, manufacturing excellence. I also thank our panelists, Mr. K.V. Nachiappan, Director, Swelect Energy, Mr. Krishna Arjun, AVP Technology, Swelect Energy, Mr. Manish Asija, Founder and Managing Director, Impossibilities Private Limited, Mr. Sridhar Sundaram, Assistant General Manager, Maintenance and Projects, Swing Setter, India Private Limited. Ladies and gentlemen, this webinar was powered by Swelect Energy Systems Limited. For more engaging discussions and webinars, join us at REI Online Connect. I would also like to take this opportunity to invite you on behalf of Informa Marcus to the 17th edition of REI in October. Thank you once again. This is Amit, your host, signing off. Thank you.